Okay, well, writing down two triangles is a terrific start because you do need to draw two triangles. However, it's a little bit more detailed than that. It has to be what? Isosceles, and an isosceles triangle is what kind of triangle? Two sides are congruent. Okay, so there's one of my two isosceles triangles that they wanted me to draw. But they wanted me also to set this up in a special way so that the perimeter of this triangle would be 4A plus B. So how can I label the sides in such a way that that will work out? Say again? 2A?
Yeah.
So if I call this side 2A?
No, the 2A.
Oh, not that one, this one. So if I make that side 2A, since it's congruent to the other side, then this also has to be 2A.
And then the base is B.
And then if I make the base B, then the perimeter of that will add up to 4A plus B. Awesome. Okay, but they asked us to do it with two different triangles. So here's another isosceles triangle. The perimeter of this isosceles triangle is also 4A plus B. What's another way that I can label the sides to make this have the same perimeter as the other one? What? 3A. Where does a 3A go? Okay, but what's the problem there? But what has to be true about these two sides? The same. So I can't go 3A and 1A, so that's not going to cut it. Yes, somebody had a hand up in the back. No, shot down. Anybody?
Wait, I watch 1, 2A on the base.
Can you put what?
1 and 2A on the base.
You want a 2A down here?
Yeah.
Okay. Yeah, you can actually. There is a way to make that work. Sarah? Okay, good. That'll work too. Okay, so if I make each of the top sides be A, and the bottom side, the base side, be 2A plus B, then that is another way for me to get what I need. All right. And then the other way that you can do this is if you just throw some fractions in there. So you can have a half a B and a half a B and then a 2A, and then you can do all kinds of different things. Okay? McGuire? You good?
Yeah.
Okay, nice round yesterday. All right, what else?
15.
Fitting. Oh, good. 15. Use your ruler and protractor. So once again, let me just remind you that you're probably going to need to get a ruler and a protractor of your very, very own sometime soon, so that you can do these at home and not have to always rely on using my stuff. All right, use your ruler and protractor to draw a triangle with one side 9 centimeters long. So I should probably start by...
I don't know.
Making a side 9 centimeters.
Making a side 9 centimeters. So I'm going to make this side
Can
be...
we just like shorten it up and say it's 9 centimeters?
It says use your ruler and protractor. They want you to...
For a straight line.
It says to, but.
It takes up way too
I
much
don't know if I can
paper.
let you do that. I might get fired.
I didn't make
Math
that.
police might come in and
I
fire
didn't
me.
make that much room.
Okay, and an adjacent angle measuring 45 degrees. So now I am going to take and put this protractor there, and I'm going to make an angle that is 45 degrees. Bless you and Gesundheit. So this was 9 centimeters. This is 45 degrees. And is that all I need?
Yeah.
Jason, angle measure 45. Okay, so then if I take and connect the two other sides, then I got myself a triangle. Okay, no big deal. Can we draw a second triangle with the given measure that's not congruent to this one? Got one vote for no?
Yes.
Got one, couple votes for yes,
Yes.
few votes for yes, the yeses are weighing in. What's one thing that I could change?
The side length.
Okay, this side length has to stay 9 centimeters, right?
Yeah, but the
But they never said anything about that, yeah, so if I wanted to, I could extend that one out and then make it like that, and then I would have a different triangle. Okay? So if they only tell me one side and one angle, then there's a lot of different triangles that I can use that will match that. Okay? All right, so did you say 16?
Yeah.
Okay, use your ruler and protractor to draw triangles, one angle measuring 40 degrees. So it doesn't say anything about the length of the side, so I'm just going to start by making a random side length. And then they want off of that 40-degree angle. And then this is where things get fun. Now the opposite side needs to be 10 centimeters long. So this is 40 degrees, so that has to stay 40 degrees. And my opposite side, so this missing side right here, has to be 10 centimeters long. How can I figure out how far to make these things go until this is going to be 10 centimeters? Draw the 10 centimeters first. Okay, so let's get this guy back up here. Any old place?
No, I don't see why not from the
I don't
top.
see why not either. Except for what do I have to, it needs to go so that it matches up with it somehow, right? Okay, so I'm going to be fancy schmancy because that's just how I roll. I'm going to take my compass out. And I am going to extend that out so that it's 10 centimeters, right? And then if I draw this, which we can't see, but now if I take and extend this line here until it crosses that arc, and apparently that's going to happen off the page, so that's kind of done. Let me redo this. Okay, come here. Hey, come here. There we go. Okay, so let me do that again. So I have this compass set up so that it's 10 centimeters spread. If I make this arc like that, now I know that no matter where I draw this side, it's going to be 10 centimeters, right? So now to figure out where I should do that, if I take this line here, or this side here, and draw that until it hits that arc. Now when I connect these two missing sides, since I used my compass to do that,
There you are.
then I know that this is going to be 10 centimeters, okay? So that's a little bit tricky to get that 40 degree and the 10 centimeter thing in there. Okay? Well, hold on. There's more. Can we draw a second triangle with the given measurements that's not congruent to this one? Yeah? How can I do that? What's that? But if I extend the, oh yeah, okay, you're right. So if I extend this one, then it would change this angle, but it would still be 10 centimeters. Okay. So yes, we can mess with that if we need to. Okay. What else? 23, 22, 22, 23, 22. Okay, so let's figure this one out. So which one do you have? On your, which one did you, I have the answer in my book, I don't know which is the original. Okay, so the negative for, the one with the label.
This is number 16.
Okay, so they give you shape with 1 point, right? They give you a shape with 1 point right here, right? And then another one is at 1, 1. And another one is at 2, 4. And another one is at -3, 5. So there's my original thing. Okay, and then it says use the ordered pair rule. XY goes to x plus 1, y minus 3. So we didn't really talk about this crazy notation, so I can understand why you are a little bit confused. What that means is you are going to take the x coordinate of every one of those points and add 1 to it. And you're going to take the y coordinate of every one of those points and subtract 3 from it. Okay? So that means I actually am in a little bit of trouble here. Because if I subtract 3, I'm going to go down. Oh man. Okay, we'll just have to make it up. So this point right here goes where? If I add 1 to the x coordinate of this point right here, where will it move to? Right, left, up, down.
Oh.
To the right 1.
Right.
So instead of being at -3, now it's going to be at -2. So that's the x plus 1. And then the y minus 3 means it moves down. 1, 2, 3. So my new point is right there. Okay? Same thing with this one. X plus 1 means it moves up, down, or right or left. To the right 1. And then the y minus 3 means it goes down 1, 2, 3. So it's going to end up there. This point also goes over 1 and down 1, 2, 3, down to there where you can't actually see it. And this one goes over 1 and down 1, 2, 3 to there. Okay? And so that will give me my new chape. That's franche. Oh shit. It's not true. Made that up. So do we have to answer any questions about these two shapes?
Yes.
Do the two quadrilaterals appear congruent?
Yes.
Yes, they do. And we're not going to check our answer with tracing paper, so forget about it.
They just got serious.
Huh?
Just got serious.
Jack's coming off. Things are getting serious. Status there going there.
Okay.
Okay. All right. And then 23. Okay, 23, this is one of those very realistic problems that shows you how useful geometry can be in your everyday life. Okay? So they are asking us about this situation, which occurs, I'm sure, quite frequently in many of our days, which is I have a bunch of, are they metal rods?
Yeah, no.
Thin rods glued together in the shape of a triangle. And I want to balance them on a ruler, and I need to figure out where to put that ruler to make them balance. Now, it is hard for me to think of a day that has gone by where I have not had some configuration of thin rods glued together in some sort of shape, and I'm trying to, you know what I'm thinking?
I know what you're saying, yeah.
We were working on that in the golf band just yesterday. We were like trying to, yeah, because we had the, no. Where would you put the ruler? Luke?
On the bisection angle of the vertex angle.
Okay, oh, nice. On the angle bisector of the vertex angle. Okay, so he's saying we are going to put that ruler right along there. Is that what you're talking about?
Yeah.
Okay, good. And so all of these points right here, since he said it's the angle bisector, those would be the midpoints of those rods. And so, yay, my triangle balances, and I feel good about myself. All right? Yeah. Is that it?